So, hello doctor, my name is Michael Foley. Nice for you guys to meet me. I wanted to just make a quick video. All of the demo material is on its way to your office now. And so I thought I would do just a quick run through of all the parts and pieces that are being sent to you, as well as the surgical kit. Show you a couple other little things. Since we're not face to face, this is what I would normally have the opportunity to show you, but this will have to do. So I'm gonna grab a couple different things here. First off, this would be titanium, very soft, flexible material. This would be plastic. And this is the bicarbo. I'm literally trying, you can't break it. That is the bicarbo. This is the key to the success of our system. This is the material that is used for the screw. So zirconia is really hard, so the implant, the abutment, two really hard, not flexible pieces of zirconia sitting on top of each other. They're connected with a bit of a bevel. You have to have something that is exceptionally strong in between the implant and abutment to lock the two together. All of the forces are on that screw. This has been a tremendous, this is the heartbeat of our company, and this is the reason that we're the fastest growing ceramic implant company in the world by far. This is why our system has been so successful. This screw has been, in the United States, I have never had not one time has an implant screw been broken, fractured, chipped. It's been tremendously successful. What I would want you to remember is it is designed to be single definitive use, meaning if for any reason you need to unscrew it, get a new screw. We also want to be careful when we send it to the lab. Don't let the lab manipulate it too many times. Be very careful. Make sure the lab is using the right driver. Make sure you're using the right driver. That's the only time that we ever have any issues. It can become the head of the implant. You can kind of distort the head of the implant. So what I've sent to you is this is like my little demonstration booklet. What I didn't send to you are these four here. So we'll go through them together virtually. First off, this is zirconium. See that? Zirconium, the rocks, the stones. These are a metal. Zirconium with an M is next to titanium, actually just below titanium on the periodic chart, and it is a metal. When people ask you the question, and your colleagues, your clients, your patients are going to say, is zirconium a metal? Yes, zirconium is a metal. The material that we're talking about is zirconia. So what happens is that zirconium metal goes through an oxidation process by which it becomes a bioceramic powder. So this would be, if they were to take that same zirconium metal and put it into a rod, it would look like that. Still a metal. But what we do is we process it. So it goes through a chemical transition by where it becomes a white powder, and by all definition, all of the characteristics of that original metal are lost. It is no longer magnetic, no longer thermoconductive. It is now a white powder, and it is considered, by chemistry definition, a bioceramic. Okay? From here, there's a couple different ways that the implant companies can process the implant. You could take that powder, put it into an injection mold machine, press it into the shape of that implant. That's option one. Straumann and Ceramic press their implants together, and that's how they come up with their shapes. The other option is the way that we do it, and Z Systems does it. It's a much stronger, much denser material, and that's what allows you to be able to prep our abutments. So it's a material that, the way the molecules combine, it's a trabecular system, so these molecules really bind tightly, and that's what allows you to prep the abutments without worrying about inducing a fracture. So you can prep the material without putting a fracture into it. The way that works is you take the same powder, press it, heat it, and sinter it into little rods. So our little rod looks like this. You can see that there. And then we have these special diamond cutting machines. This is, again, one of the big advantages of Xeramax, is that we've learned how to cut this very dense, very hard material. You have to have some special diamond cutting machines that we actually invented in order to cut this material. Okay? So what I've sent to you is, it's my little demo book. So this is what, if we were live together, this is what I would show you. In the top you have an implant, you have the healing abutments as well as a cover screw, you have the temporary abutment. This is a peak temporary abutment. They're very easily preppable. It's just a medical grade plastic polymer that can be very easily prepped. and it has its own screw. The screw only has 20% of the carbon fiber threads, so that bicarbo that we were just playing with, it's very, very dense. This is not the same screw. Do not want to leave this in long-term use. This is designed to be a temporary screw, okay? You have two impression transfers in here, an open tray and a closed tray. So just like a traditional titanium implant taking technique on fixture level, so implant level impression taking technique, as well as the lab analog. So you would take your impression, it's two parts. You have the impression piece that sits onto the implant, a black screw that goes through the impression post, spins into the implant, place your impression post onto the implant, take your impression, attach the lab analog, send it off to the lab. They will use the lab analog to pour up their model that looks just like the situation you had in your mouth. There's a video online that I can send you the link to if you're not familiar with this, but it's the same as a traditional titanium implant system. Lab screw. So the green screw is a lab screw. Do not use this as your final screw. And then we have three different abutments here. You have a 1 millimeter tissue height or collar of the abutment, 2 millimeter, which I don't have in my kit, but you have in yours, and a 15-degree angle. All three of these use the same screw. So there's only one screw size, regardless of whether you're talking about the regular body, the wide body, the 1 millimeter, 2 millimeter, 15-degree angle, all the same screw, which makes it a lot easier. Down at the bottom, I've included a drill just for your reference. This is the implant pickup. So this is the tool that will actually hold the implant, and it has the same tip on it so that you could place the cover screw, which comes with the implant. The final thing here is it's also a driver. These are all latch type drivers, so they'll fit in any prosthetic wrench. And the prosthetic driver is kind of like an aggressive Phillips head for this system. So that's what I've sent you. I look forward to reviewing it with you, but I wanted to just give a quick overview prior to a phone call, and so that you have a little bit of a heads up when you get the parts and pieces and you want to roll through them. Here is the surgical kit. It's a very, very nice, very concise and easy surgical kit. I'll send you a high-def picture of the surgical kit. You have your ratchet wrench. You have the adapter that fits into the ratchet wrench. And then all the other tools are latch type. So those would all fit into this adapter. This is really a prosthetic tool, or for placing the implant. The situation or the system of the drill kit is very, very easy. In our kit, you have a rose drill. So this is your initial marking drill. You have a 2.3 pilot drill. This is the only drill in the kit that has the lines. So 6, 8, 10, 12 marking drills for your depth. So that's the only drill in our system that you will need to look at the black markings to find your drilling depth. You have a guide pin that would fit that 2.2 initial drill. You then have a drilling sequence that's based on the length of the implant that you're choosing. So you have a row of 8 millimeter, 10 millimeter, 12 millimeter, and 14 millimeter implant diameters or lengths, diameter of the drill based upon the length. So let's say you're placing a 4.2 by 10 millimeter implant. You're gonna go rose drill, pilot drill, immediately switch down to the second row because that's our 10 millimeter length. You have a small body, regular body, wide body. The 4.2 is our regular bodied implant, so you would stop at the second drill. This would be the final drill. And if you look at this drill closely, it is, you've got kind of like a triangular portion. So the black piece is carbon coated, and that would be the length of the actual implant osteotomy. So when we're talking about a 4.2 by 10 millimeter implant, we're talking about 10 millimeter intraosseous. The total length of the implant is actually going to be 11.6. So the drills follow that same guide. The black portion will be the 10. The space in between that collar, the polished silver collar, and the black triangle of the drill is 1.6 millimeters. So if you want to place this implant at bone level or slightly supracrestal, which is the recommendation of the book, you would go to just below the bottom of that ring. We'll go through this together, but I wanted to give you a quick overview. All of the rest of the kit this is an expansion drill. It's listed in your kit as extension. It's really an expansion drill. So if you're in very, very dense bone, you have the ability to prep that apical portion with this expansion drill. Again, you've got another set of parallel pins or guide pins to depth gauge to show you your angulation as well as the drilling depth. And those are all fitting to the diameter of the drills. Lastly, you have the taps. Ceramic implants are not as self-cutting as traditional titanium implants. you will tap much more often. D1, D2 bone, we always recommend tapping. This will be something that you gain a better feel for as you place more and more of them. Ceramic implants don't have those big beefy blades to really dig into bone. So you'll want to and need to tap much more often. All the way on the left side of the kit is the drill extender. So if you need to extend the length of the drill, this is just a latch type extender that your drills can fit into. You have the pickups. So these three are going to be empty for now. We don't quite yet have the small bodied 3.5 millimeter implant, although it's going to be coming very soon. So your kit then has a 20 millimeter and a 25 millimeter length pickup. This is your implant placement tool. What's neat to pay attention to on the implant placement tool, one, you've got a little plastic tip that's the retention ring. And then you want to pay attention to this little groove that's right at the top of my finger here. This little groove is designed so that the driver, this, will break at about 50 Newton centimeters. This is a safety feature. Rather than putting any undue stress on the implant, ceramic implants are proven to not like high compressive forces. You're not placing this implant at 80, 90, 70 even Newton centimeters. The ideal range is 30 to 45 Newton centimeters. So this driver will break around 50 Newton centimeters. Below that in your kit is what we call the rescue pickup. The rescue pickup is, as it described, it's a bailout. It's a tool to reverse an implant. So let's say you placed your implant, it's still sitting about 3 millimeters above the bone. It's too high for any reason. Your drill may have, your placement tool may have already fractured and broken. The rescue pickup doesn't have that breakaway. So you can go back into the implant with the rescue, slowly reverse it out, come back and tap that site if necessary, and then go back to replacing the implant. The final tool down here in your kit is the prosthetic driver. So this is the one that I showed earlier. This is used for tightening the final screw, the temp screw, can be used for placing any of the healing collars or the cover screws. That's really what I wanted to show to you today. I look forward to talking to you. Please get a time scheduled together where we can go over this in person and go through a little PowerPoint presentation of the company, the history, where we're going, talk about some of the new things that are coming out, and then answer any of your questions in more detail. Thank you very much. Nice to virtually meet you, and I look forward to speaking with you soon. Cheers.